In example 1, we want to solve the linear system using substitution. When we're using substitution, we're looking to have this situation right here. We need one of the variables to be solved for, meaning that it's on one side of the equal sign by itself with no coefficient other than 1. And that number here, if you wrote it, would be a 1. Then we're going to look in the other equation, and we see a y right here. So what we're going to do is we're going to take this y out, and then we're going to substitute everything that y is equal to, and we're going to do that in parentheses. So y is the same as 3x plus 2, so this y can come out, and 3x plus 2 can come in. Now you might be wondering, why in the heck would you want to do that? Well, here we have two equations and two variables, and it's very hard to solve that right off the bat. Now, using substitution, we have one equation in only one variable. And so this allows us to solve for one of the variables, and then we're going to be able to substitute that back in and solve for the other variable. We're going to use the distributive property here first, so that'll be 6x plus 4 is equal to 11. We'll combine like terms, so 1x and 6x is 7x. We'll subtract 4. 7x will be 7. We'll divide by 7, and we find x to be what we think might work would be 1. Let's go back to the original equation here, which is y is equal to 3x plus 2, and instead of x we'll use 1, and that'll give us the value of y. So that's 3 plus 2, or 5. When we have an x and a y, it's useful, and oftentimes you'll see it written like this. You'll see the x and the y written as an ordered pair, and this is our solution. To check our work, we're going to take the equation we didn't use last. So we used this first one last. Let's use this one then to check. So our check is simply going to be taking the other equation, x plus 2y is equal to 11, and substituting these values in and seeing if we get a true statement. So x is 1, y is 5, 1 plus 10 is 11. So as long as we've done our math here correctly, we've also checked with the other equation, and we're fairly confident that that is the solution. Let's try the same type of approach with the next one. And this time, the x is solved for in the first equation. So I'm looking at this one right here. What we're going to do is we're going to go to the second equation, take the x out, and then substitute everything that x is equal to. So instead of writing 4x, we're going to write 4 times 2y minus 6. Then we have plus 6y is equal to 4. I'm going to move this up just a little bit so you can see it better. We'll do the distributive property, same thing we did before. Oops, that's going to be a 24. We'll combine like terms, so 8y and 6y is 14y. We'll add 24 to each side. 14y is equal to 28. Divide by 14, and we find y to be 2. It's okay for these to be work out to be decimals or fractions, but it seems like for these first couple here, we've got just integers to deal with, and that does happen a lot. So we're going to go back to the first equation. X is equal to 2y, but we think y is 2, so we'll substitute in again. X is 4 minus 6, and x is negative 2. So we've got negative 2 as our solution. To check, we're going to use the one we didn't use last, so it's this one. And I always go back to the original. So the check here is going to be 4 times x plus 6 times y. Remember, x we think is negative 2 and y we think is 2. And oops, that's going to be equal to 4, hopefully. 4 times negative 2 is negative 8. 6 times 2 is 12. And negative 8 plus 12 is 4. And we get 4 is equal to 4. So this one does check out. We have just 3 more to work, and if you're getting lost, try to pause the video. I'm going to go through these ones fairly quickly now that I've kind of explained what's going on with the other one. So what I'm seeing right now is this y here and this y are the same, and on the top the y is already solved for. So I'm just going to replace that y with everything it's equal to. In this case it's 2x plus 5. Now there's a 1 here, so we really don't need the parentheses. I just wanted to show those to you so that you get used to substituting with parentheses, because if there's anything else other than just a plus sign here, we have to deal with it. But actually we can combine the 3x and 2x, which is 5x. We're left with a 5. So we'll subtract 5. 5x is equal to 5, divide by 5. And x will be 1 in this case. If we use the first equation, y is equal to 2 times x. So that's 2 plus 5, or 7. So the ordered pair that is the solution to this system of equations we think is 1, 7. Let's check it with the other one. So the one we didn't use last was 3x plus y, or 3 times 1 plus 7 is equal to 10. 3 plus 7 is equal to 10 is a true statement, so this one's checked. Okay, let's try another one here. In this case, this y is solved for, so we're going to take this y out and replace it with x minus 7. So we've got x plus 4 times x minus 7 is equal to negative 8. We'll use the distributive property here, 4x minus 28. Combine like terms, and we move this up a little bit. There we go. We'll add 28 to each side. 5x is equal to 20, divide by 5, and x is 4. We'll go back to this equation. Y is equal to x minus 7. So y will be negative 3. Our solution then is 4, negative 3. To do our check, we'll choose the other equation, so this x plus 4y is equal to negative 8. So there's x plus 4y should be negative 8. Positive 4 times negative 3 is negative 12, and 4 minus 12 is negative 8, so that one is definitely checked. Alright, just one last one here. Got part E. And part E, we need to do a little bit of work first, so we're going to divide this equation by 5. We've got y is equal to 3 there, so we actually solved this one pretty easily for y. We're going to take the y out here, and we're just going to substitute that 3 in. So we've got 3x minus 3, we'll add 3. 3x is equal to 3 divided by 3, and x will be 1. So the ordered pair that solves this is 1, 3. You can double check this. 3 times 1 is 3, minus 3 is 0, and if y is 3, 5 times 3 is also 15. So this one does check.